Okay, so welcome to the last webinar. We've had two so far. This is going to be our last informative webinar where we teach you how to get accustomed to the RoboCup Junior Maze competition. This is the simulation version. And today we're going to talk about victims and OpenCV. But before that, one thing you guys should definitely know about, I'm going to share my screen. One thing you should definitely know about is if you go back to this, srbots.com/rebots.html, this right here, this is the link we've always been using. And you go to this card right here, this share your work and recognition. After today, you guys will know all the API calls necessary to tackling the rescue maze competition, the simulation version. And what we want you to do, and we highly encourage it, is for you guys to go and try coding at least a portion of the maze challenge on your own. And then what you can do with that is you can actually upload it to this link right here. It's just a Google Drive folder. So if I go into here, it's loading. If I go into here, you guys can upload your .cpp and your makefile. If you have specific stuff inside your makefile, just make sure you put it, I guess, in a folder with your name or something like that. Just make sure your file doesn't go all over the place. But you guys can upload your code to this spot, and we'll actually test it out. We'll run it on our own, and then next time, on the 27th, there's another online session, and we'll actually talk about some of the better submissions and basically do a running of a simulation of the rescue maze competition. So we're just going to run your code, and we're going to show who has the best code, right? So we highly encourage you to upload your code to this link right here. And the field, there's a picture right here. This is just the field from day 2 from yesterday's webinar. So if you go to the GitHub page, which remember is always in, let's see, it's the GitHub page that we've always been using. It's the GitHub/VictorWho3, and then you just go right to sample code. And then it's the day 2 world, and you guys were working with it yesterday, so you guys should know what I'm talking about. But basically just code a robot controller so a robot can go through that world, this world right here, and then score as many points as possible. And make sure you guys upload your .cpps to this folder. So that's about it for the introduction. We're going to get started with Victor, who's going to talk about victim detection.
All right, so we went over how to use the sensors, including the heat sensor and the camera, in order to look at victims and recognize them. But after we do that, we're also going to have to actually report them to the game's scoring engine in order to actually get points. So the way we're going to report them to the scoring engine is with something called an emitter. And the emitter allows us to communicate with the scoring engine. So how we're going to report our victims is, first, we need to set up the emitter, which involves including emitter.hpp, and as well as getting it from the robot. So it's kind of like a sensor, but it doesn't sense anything, and you don't actually need to enable the time step. You'll see I don't do that down here. That's because it's not exactly a sensor, but it's still a component of the robot. So the way we're going to use the emitter is we're going to have to report the victim to the scoring engine. And there's 4 pieces of information we need to report. We need to first of all report the ID of the robot, and then the X and Z position of the predicted victim, and then the type of victim that we think it is. So first of all, I just set a constant int to store the ID of the robot. So for instance, robot 0. Now, the format of our message to the emitter is going to have to be a byte array or a character array. So we're going to create a character array, and since it's going to be in the form of integer, 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 character, that's going to be a total of 13 bytes. And we're just going to use this memcopy function in order to copy all our information into the array. And we got memcopy from this library, cstring. So first of all, the first piece of information we're going to need to have is our robot ID. So that's 4 bytes long. We copy that into the start of our array. And then down here, for instance, if we see a heat victim to our left side, which means that the temperature is around 37. So I just set a threshold of greater than 35. Then we're going to copy the next 2 values in, which are the X position and the Z position. And since we don't know the exact X and Z position of the victim, we're going to just report the robot's X and Z position. And we got this X and Z position by using the GPS. Additionally, these are also integers. They're not doubles like the usual value that you get from a GPS. And the scoring engine wants this position to be reported in centimeters. And that's because it wants to keep it as an integer. So meters are too low of a resolution to report as an integer. So we're going to convert it to centimeters by multiplying by 100 for the X and the Z. And then down here, the next piece of information we copy is the X pos, once again, integer, so 4 bytes. And then we copy the Z pos, which is also 4 bytes. And we don't care about the Y position because, once again, the robot's height should not really be changing within the world. And if it does, that's a pretty bad sign. So you can assume your Y position is going to stay constant regardless where you are in the world. And the final piece of information is a character. So that's only 1 byte. That means we can just set the last element of our character array to whatever victim we believe it is. And the possible values for victims are T for temperature victim or heat victim, H for the letter H, S for the letter S, and U for the letter U. And then after that, we just call emitter -send. We pass in our message, which is our array, and we pass in the length. And the length is always going to be 13 bytes. Okay, so if I demonstrate this, compile, and then reset the world. All right, we're going to take robot 0, and we're going to drag it right next to heat victim. And the robot needs to stay stationary for a minimum of 3 seconds in order for the scoring engine to allow you to score the victim. So after 3 seconds, it's going to say successful victim identification. You'll notice that the red light goes off after you score the victim to demonstrate that the victim has actually been scored. And you get plus 10 points. And this points was just for entering the grade checkpoint right here. These checkpoints allow you to revert back to that tile after a lack of progress. So they also give you an additional 10 points. So we have a total of 20 points. And the other thing that you can do with the emitter is that you can also report your when you return home after you traverse the entire maze. So the advantage of that is that you're going to get an exit bonus if you're able to if you manage to find where you started from within the time limit. So down here, the only difference is that instead of sending T, HS, or U, you send E, which stands for exit. And all you have to be is in this green square, which means your home square when you send the message. So if I comment this part out, oops, I'm gonna need to build that. And I think, oh, because I left this bracket here. All right, so if I run that, immediately it's going to say successful exit. And you'll notice we got points for exiting. And the amount of points you get is going to depend on the victims that you actually scored throughout the run. And it's just a bonus addition onto the amount of the points you get. Okay. Now we pretty much have all the tools we need in order to actually start building a full robot controller. So we know how to use the motors, we know how to use the sensors and do victim detection, and we know how to report the victims. So now one exercise you guys can do is if you have the world downloaded, there is, actually I shouldn't have stopped sharing screen. There's a heat victim right in front of the home tile. So that should be, I'm not a heat victim, an H right in front of the home tile. So that should be an easy enough task if you just move forward enough to get into the radius of the H victim and then report the H victim, then you should be good. So another thing I should mention is that if you're going to report a victim, you need to be within a certain radius from that victim, and it's going to be 15 centimeters, which is around half the width of a single tile. So as long as you're within 15 centimeters and you stopped for 3 seconds, then you should score the points. So with that in mind, we're going to take a few minutes to let you guys try this out. So all you're going to have to do as an exercise is to move the robot forward and then stop right before the H victim within 15 centimeters and then report it to the scoring engine. So we're actually going to stop and take a few minutes for you guys to try that out. And if you guys do have anything to show us, then please do like put in a comment in the chat or like raise your hand, use the like Zoom raise hand feature, and we'll actually let you share screen if you have anything to show us. Other than that, I'll go over one way to do it after a few minutes. And just one question from Brian. Do you wait 3 seconds before or after reporting the victim? You wait 3 seconds before reporting the victim. So your robot has to be stationary for at least 3 seconds in order to actually, in order for your request for the victim report to go in. You can try to submit reports before 3 seconds, they just won't do anything. So it's not until after 3 seconds that they actually do anything. All right, so we'll give a few minutes to do that. And if you have anything, then feel free to like raise your hand and we'll let you share.
And if you have any questions, also be sure to raise your hand or message us.
Somebody had the question of where's the world download. Um, the world download is located on our GitHub once again. So let me share screen for that. Okay, so at this GitHub page, Webot sample code, you'll find our entire collection or repository for each seminar and the associated worlds and sample code for that specific day. So today's day 3, so you can find the world that we're using under day 3, and this world called day3 map.wbt is the world I was currently just demonstrating. So this is pretty much the same as day 2 world, except we added more heat victims for you guys to play around with. And what you want to do is you're going to have to download this entire repository by hitting clone and download zip. But once you have this, move this WBT file, which is like the world configuration file, into the Webots project rescue maze release 2/game/worlds, and it should reside in the same directory as day2 map.wbt. And the reason why this is these WBT files are just the world configuration files. They don't actually have the assets uh, um, stored inside of them, which is why you need to put it within the worlds directory of this folder in order for it to be usable. And you can also find the sample code that we're going to go over today in here. The emitter demo is what I just demoed with score reporting. And we're also going to do an OpenCV example. So I hope that answers your question. Okay, so it's been around more than 5 minutes. So hopefully you guys had this time to start trying to write a controller to detect the first victim over here, or at least gotten the world downloaded and set up Webots for this environment. So I'm going to go over a very basic example of how you integrate your movement with getting this victim. So here is a practice example file. This is not yet uploaded to GitHub, but we can upload it afterwards. Pretty much the whole goal of this is that it just achieves the purpose of getting the first victim and nothing else. So everything is generally hard-coded for that purpose. And this is just to get you a sense of an idea of how we're going to integrate motors and camera and the emitter all together into one program. So once again, we're gonna have two utility functions right here. GetDist is gonna take two positions and return the Pythagorean distance for the x and the z, because once again, we don't care about y. And this array equals, you've probably seen this before yesterday when we were doing camera recognition that just compares two arrays and see if they're equal. And you'll see pieces of the code we did today, which was the emitter stuff, because we're going to use our emitter to report this H victim. So we set up our message like we did in the emitter demo, as well as we have all our sensors we're going to need, like the GPS, emitter, motors, motor encoder, which is the position sensor. And all we're going to do is, since this victim is right in front of it, we can just move forward a certain amount. And if you remember from day one, we can use the set position function in order to set a designated distance we're going to move forward, which is going to be 35 radians. And we're going to set the velocity to be 5 radians per second. And next, we also instantiate our camera and enable all our sensors down here. So the main idea of how this is going to work is the robot, because we set the position, is going to move forward until it reaches 35 radians, and then it's going to stop. How do we know that it's going to stop? Well, we're going to have our encoder get distance, and it's going to start. This if statement is going to activate a little before it stops at 30 radians to give it like some space. After that, we're just going to assume that we're approximately right here, and we can report the H to our emitter. So with our current camera recognition method, where we use the Webots built-in color recognition, you won't be able to distinguish H, S, or U's. So you won't get points for determining if it's an H, S, or U, because you don't know if it's an H, S, or U just with the color recognition of the camera. But you still get points for having a successful victim detection in the first place. So you can detect there's a victim and not know its type and still get some points. So we're going to send that once we're close enough to the victim as told by our encoder. So I'm going to build this, nothing to build, but we're going to attach the controller to robot 0 to practice example. And 1 second, close it, that's it. Practice example. Oh, one thing is that I might have deleted earlier my robot 0. Yes. Yep. Sometime earlier I deleted my robot 0, so I'm gonna have to retrieve that. For right now, Jeffrey, do you want to talk about OpenCV installation? Because that might take a while.
Sure. So as Victor said before, you guys, as of right now, through recognition colors, you guys can determine whether or not there is a victim on the wall and where it is. But you can't differentiate between the H, S's, or U's. That's going to require some camera processing, some image processing. And one way to do image processing is through OpenCV. And basically, it allows you to work with matrices of where each matrix is a bunch of pixels, and each pixel is an RGB value, and the entire matrix represents an image. And OpenCV really helps you out to really work through the image and determine what letter you see on the wall. So today we're going to install the OpenCV library so you guys can use it. Now, right now, since we don't have infinite time, we're only going to cover Windows. So if you're running on Mac, you might kind of be on your own, or you could go, actually, you could definitely go on the Discord that's on our, let me share my screen. Go to the Discord or forum that's right here on this website, so Discord or forum. And if you can't figure it out on your own, you can ask for help. And we hopefully will provide you with links in a fashionable amount of time, in a reasonable amount of time. So without further ado, those of you who are using Windows, you guys can follow along. But if you if something goes wrong halfway, we're gonna post instructions on our GitHub page. Once again, if you don't remember how to get there, you can click on one of these access these challenge here's, and then it'll bring you to our GitHub page. And then if you go to the root directory, over here in day 3, we're gonna post instructions, detailed instructions with pictures about how to download it, how to install the library, and we're also gonna post this meeting on YouTube. So don't worry if you get lost halfway through. There'll be various resources you can use to install OpenCV. So yeah, let's get started. Now, the first thing you need to do is actually download the files that make up OpenCV. And to do that, you guys can go to this card right over here. It's the June 25th one. And then click on Install OpenCV right here. And it should lead you to a GitHub page. So this one right here. I'm going to close out of that. Leave that open. So it should lead you to this page right here, right? And from here, you're going to click on zip right here, and then it will download a zip file. And then you can open it when it's finally done downloading. All right, well, it's taking a while. I've already downloaded beforehand. So go to downloads, and it should look something like this folder right here. And then what you're gonna do is you're gonna hop into it, and you're gonna do an extract all. And then we're actually gonna save this right in our C directory, right there. And then you're gonna hit extract, and then it's gonna pull all the files from the zip folder into your C drive. Right, so after you hit extract, I'm not going to because I already done it. So then if we go to our C drive, it will pop up right here as a regular folder, right? Then we're gonna go into here, and we're gonna go into x64. Well, that's depending on your machine, but for you guys, it should be x64, min-gw, and then we're going to bin. And we're gonna remember this spot right here. This is a pretty important spot for later, right? So then we're gonna minimize out of this. And now we have the files that make up OpenCV, but now we have to add it to our path. So to do that, we're gonna go down here into search, and then we're just gonna look up path, right? And then it's gonna pull up this edit the system environment variables. I'm gonna click on that. Okay, from here, we're gonna click on environmental variables. Okay, then we're gonna scroll down here. I'm gonna find this path right here under system variables. And then we're gonna hit edit. Okay, and you'll see a big list. Now we're gonna create a new one. And if you remember from before, we had this whole little path laid out for us. And for actually all of us, it should be the same, assuming you all stored it in this in your C drive. So this link right here will be the same for all of us. So if you just click right in here, it'll turn into text form, and we can actually copy it. If you hit Control-C, then we're gonna hop back to this path right here, and then we're gonna create a new one, and we're gonna paste it in like this, right? And then you're just gonna hit OK. I already have it up here, so I'm just going to take this out. So after you hit enter, it should look something like this. And then after that, we're good to hit OK, and then OK again. So now we've added it to our path, and OK again. So now we've downloaded the files, the pre-built library for OpenCV, and we've added it to our path. So now to create a robot controller that uses OpenCV, there's one more thing that we have to do. So I'm going to open up my Webots. Okay, I'm actually going to open a different world. I'm going to go to my day 2 world, and worlds, and day 2 map. We can wait for this to open. Okay, now I want to create a new robot controller that uses OpenCV. So we're going to go to Wizards, New Robot Controller. Go next. We're going to be using C++. Next. We're going to use Webots. Next. And then I'm going to name it OpenCV Demo. And that's all good. Now, we have one more step to take. We have to actually modify our makefile so that it knows where to find the OpenCV libraries. So what we're going to do is, if you go to your folder, this is the folder that you should have downloaded or cloned off of GitHub. You should have the day 1, 2, and 3. What you're going to do is you're going to find the controller folder, which is where this all gets stored. So since I created my world using the day 2 world, I'm going to go into day 2. I'm going to this folder, go into this folder, and I'm going to controllers. Whenever you create a controller using this wizard, this controllers folder is where all your files are stored. So your .cpps and your makefiles all go in here, right? And as you'll see, I have my OpenCV demo here, which is what I just created. We're going to open this up, and then we're going to look at this makefile. So I have Notepad++, so that's going to be my text editor to edit makefile. But I think pretty much any text editor should be fine. So I'm going to edit it with Notepad++. And here we have our makefile. Now we're going to hop back to our, this is Victor's GitHub with the day 1, day 2, day 3, this GitHub right here. What we're going to do, we're going to go into day 3. We're going to click on the sample makefile. And then we're going to scroll down a little bit and find lines 50 and 51. Now, what you're going to do is you're just going to copy and paste lines 50 and 51, copied, go back to your makefile over here, and find your own 50 and 51. You'll see that these are commented out for right now, but you're going to actually replace them with these 2 lines from our GitHub. So once again, you're going to take these 2 lines of code, or these 2 lines in the makefile, and you're going to paste it into your own makefile. This basically tells your robot controller where it can find the OpenCV library files that it needs to run OpenCV. And that is basically it. From there, you can just go into your Webots text editor, code some OpenCV, which Victor is going to show right after this, and you can just build and everything should work normally. Now, in installing OpenCV, you tend to run into a lot of problems. We understand, both Victor and I had a fair amount of trouble, but afterwards, if you guys have questions, you guys can stay after this tutorial and you can ask away. So that's pretty much it for installing the OpenCV library and setting up a Webots robot controller. And now Victor is going to show you some of the fundamentals to using OpenCV. So Victor? You're on mute, Victor.
All right, thank you. All right, back to Robot 0. Well, it seems like I deleted Robot 0 because it seems to exit every time, so I'm just going to use Robot 1 in this case. All right, so I have my practice example code attached to Robot 1, and if I run it, well, all it's going to do is, as the code says, is move forward 35 radians, and this is the position sensor reading. Once it gets to 35 or around that, you wait a few seconds, and then you get a successful victim identification because we're reporting right down here. Okay. So now onto OpenCV. As Jeffrey said, you're going to have to edit your make file in order to direct it to the OpenCV includes, like the HPPs, as well as the libraries and DLLs. So we have this OpenCV example.cpp, and once again, this is in our GitHub under day 3. So this is just the basics of how you're going to use a camera image and apply it onto your robot by turning it into an OpenCV mat. So here I'm just including OpenCV2/OpenCV.hpp. That's pretty standard. And we're going to be using namespace CV to get access to all the functions. And this is gonna work for any robot that has a camera because we can use the camera image as our OpenCV mat frame. So we're gonna create a new robot, and then we get our camera like usual. We enable our camera. Now, line 27 is the key line of code that links Webots with using OpenCV. So we need to convert our camera frame to something that OpenCV can use by constructing a new OpenCV mat called frame. And there's a couple things we need to pass in. We need to pass in the height of the camera and the width. And this is in pixels. So you can get that very easily by saying cam get height and cam get width. And that's going to just return the pixels in height and width. Next thing is this CV8UC4. That basically tells it that the camera frame is in RGBA format. So we want to convert the RGBA channels to something recognizable by OpenCV. So we just need to specify this. And then finally, we pass in our camera get image. And this is just a character array of our entire camera frame, like a gigantic character array. And we're gonna say void pointer because that is what frame OpenCV is gonna be expecting. So make sure you do that. After that, we just IM show frame, which is gonna display a box of the frame. So if we compile that, and then we attach it onto robot 1, OpenCV example. All right, so if we run that, and let me reset the world. Hopefully my computer can handle running OpenCV and streaming at the same time. All right, give it 1 second. I think at this point, I'm gonna restart Webots. Oh, there we go. It worked right after I stopped screen sharing. Okay, so this is the camera image provided by Webots. So you'll notice it's just staring at the other robot's back. And this is the OpenCV IM show frame. You'll notice that it's exactly, where we have to continue this. It's exactly the same as what we see in Webots. And that's a good thing because that means we just successfully converted the Webots camera image into something usable by OpenCV. So now after that, we can use anything we want from OpenCV with the camera. And that includes things like, for example, grayscaling and thresholding the image. So this should show 3 windows, the original frame, the grayscaled version, as well as the thresholded version, which is just the black and white version. So if I run this, oh, and I have to build it. There we go. And here are our 3 windows. So this is the original frame, this is the grayscaled version, and here's the thresholded version. Oh, and the simulation has to be running. And so pretty much, this just shows that you can use any OpenCV function within Webots at this point once you convert it to a frame. So anything you'd normally be able to do with a regular camera and OpenCV, you can technically do within Webots. So the point of this is to allow for improved victim recognition, because while right now we use Webots' built-in color recognition in order to detect a victim, it's kind of simulating it at this point. It's not real victim recognition. So by linking OpenCV with Webots, you can actually perform whatever object detection or image detection, image recognition that you actually want to do. So this is going to be useful in the future in September. You're not going to need this right now for tomorrow's or the day after tomorrow's mini contest. But since this installation takes a lot of effort and usually people run into a lot of trouble with it, then we thought it'd be a good idea to introduce it now and get any problems out of the way right now when you guys can ask us for help. So you guys either ask us right now. So if you have any questions right now, feel free to ask us. Otherwise, we also have a forum as well as a Discord. So I know I'm active on the Discord and I always use Discord. So if you post anything in the Discord, then I'll be able to see it. And I'm sure Jeffrey will be able to see it as well. And we can answer any installation questions from there, as well as we have an RCJ forum. So the Discord is located right here under our srbots.com/webots main page. We have a link to the Discord for a rapid response, as well as the RoboCup Junior forum. This forum is more for clarification of rules. So if you have any questions with installation, the first place I'd look is under the Discord. All right, so back to you, Jeffrey.
Okay, thanks. Let's see. I'm going to share my screen one last time. And so That about wraps it up for today. I hope, or we hope, you had a nice introduction to OpenCV. And make sure, once again, we highly encourage you, code out a simple robot controller that can handle the day 2 world, that can explore it and maybe rescue some victims. And be sure to upload your work to this Google Drive folder right here, and try and get it in by June 26th, midnight. It'll really help us out in getting some knowledge as to where you guys stand with how if you want to do RoboCup Junior Maze. And if we do receive some good support, then we'll make sure to go through with it and everything like that. So be sure, once again, to upload your code into this Google Drive folder here. Otherwise, that should be pretty much it.
We have some people saying that the Discord link does not seem to be working. All right, in that case, we have the Discord link is probably too old, so right after this, we're gonna update the Discord link on the website, and then that Discord link should be updated and it should work. So give us like maybe 30 minutes to an hour after this meeting and check back in on the main page and see if the Discord link works. Otherwise, we also have an email. So if it really gets to that point, you can also email us any questions and regarding the Discord, and we'll get on that.
Yeah, so if you guys have questions, be sure to stay on. You guys can ask us right here, right now. Otherwise, that about does it. Thanks for watching. We hope to see your work inside the folder so you can do the competition on Saturday. Yeah, Saturday.